Hi, my name is Nick Hallenstein. I'm the creator of the TRex metadata library, and I'd like to welcome you to video 2, which we're going to be using to investigate the polling trigger. Now, polling triggers are created using the TRex trigger attribute. So if you look at adding the TRex metadata library to your project, you have played around with the metadata attribute that we showed in the last video, you might be itching to find out what else there is. Well, what you'll find is there is a trigger attribute that can mark one of your actions as actually being a little bit special, in as much as it can be used to start a brand new logic app. And so for the polling triggers, we'll find that what the logic app's runtime will do is if it notices that you have if you have an operation that has the XMS trigger vendor extension in the Swagger metadata, it'll say, oh, this is a trigger, this can start a flow. And if it realizes that it doesn't have any information about a callback URL, no notification content, any of that, it's going to go through and it's going to start polling that address. It'll go through and it'll ask, hey, do you have data? Do you have data? Do you have data? And your polling trigger will respond either 200 OK to say, yes, I do, and here's the data, or it will respond 202 accepted. Yes, I've accepted your request for data, but I regret to inform you that there's nothing there. And it can provide a time for retry. It can say when there's expected to be data there. So that's essentially what we're looking at when we're talking about a polling trigger. It's going to have that kind of behavior. Now to implement that in a custom API where we're using the TRex library, what we're going to do is we're going to first write a method that has as its parameters everything we need to do, or everything we need rather, to go out and check for data. So in this case, we're going to poll for content on a web page. So we need the address to the page, we need the element selector for what element we're going to select, and then we need to maybe keep track of the last thing we saw, because we don't want to just poll and fire every single time. We only want to fire if something has changed. Now, keeping track of the last result isn't something the user is going to be able to do for us. They're not going to go and edit the logic app every time there's a new result so that we're checking for something else. Instead, we're actually going to change the visibility. So notice the visibility of that specific parameter, last result, is internal. We're hiding that from the designer so the user can't actually set that. And we're going to actually trick, or really cooperate with, the logic app runtime to set that for us. It'll keep track of what we last saw. Now, this is fine in the case of a website, but maybe you're not polling that. Maybe you're polling a file system, maybe you're polling a queue, or some other content. Maybe that's a file timestamp of the last file you saw. Maybe that's a message ID. So you can use that for any purpose. In fact, you can have any number of such parameters that are in this internal visibility that aren't otherwise seen. Now, in addition to having a parameter to keep track of what we saw last, we're probably also going to want to add the metadata that says this is actually a trigger. And so we're going to do that with the trigger attribute. Now notice we still have the metadata attribute in place, but the trigger attribute allows us to tell the logic app's runtime, is this a polling trigger that we need to call over and over and over, or is it a push trigger? Do we have a callback URL somewhere in the configuration of the parameters going in where we want the logic app to give its callback address? Well, in this case, we're not doing that. We're just polling. We want it to check over and over. You'll notice the second parameter of that is going to be the type of the result. So here we have page query result as the type of the result. And then finally, a quick results description. So page element results. Okay, so we have the trigger attribute. Awesome. Tells logic apps this is a trigger. We have a parameter to keep track of this runtime state so that when we call and we're looking to see has content been updated, we can know what it last was. But what do we do in the actual operation body? So if I take a look at the code, you'll notice that one of the first things I'm doing, other than the actual operation of going out to the web page, which you can see is hidden away in Git matching elements, is we're actually going through and we're building out the parameters for the next poll. And we're just creating a new object. It's just an anonymous type. It's not a well-defined thing. But what you will notice about it is it matches up one-to-one, its members with the parameters of the operation. This object is actually going to be used as the parameters to pass in for the very next poll. So this time around we saw one bit of content, but the next time maybe we see something else. Now it's calling result.getHash. The getHash method, all it's doing is it's going through all of the different items we found on the page and is generating a hash of it. and it's using that so that as we're passing that in, we're not passing in all the elements we ever saw. It's just a quick little bit of, it's basically a hash of what it was. All right, now, as we keep going down, you'll notice we hit an exception, the not implemented exception. So I'm going to go ahead and clear that because we're about to implement this. And so what we're going to do here is we're going to check to see if the last result doesn't match what we saw. If the last result doesn't match what we just saw when we pulled it again, something has changed, and we want to fire the trigger. We want to create a new logic app as a result of this new find. And so what we're going to do here is we're going to return a response message, so an HTTP response message using the response message method to generate an iHTTP action result out of it, where we want to say that the event should have been triggered. We should have actually fired the logic app. Now we do that through a 200 response and the body containing the actual payload or the trigger outputs. And to set that up, we're using a extension method, which is part of the TRex library, called event triggered. Now, event triggered was designed to match, or at least somewhat match up to, one of the early SDKs for logic apps, which did provide us a way to basically build polling triggers directly out of the box. And so we have the results as one of the parameters, the raw result that we want to return. We have the route name that we're going to call next. Now, that's going to be used along with the parameters for the next poll that we built earlier in the method to build a location header. Now, this location header is going to be sent back to the logic app's runtime, and the logic app's runtime will pull that location for the next poll. It's not going to keep pulling the same location necessarily. It's going to go look at the location header, and we can build into that any state that we need to keep track of. And that's a beautiful thing. All right, now we could also specify when to pull again if we need to. There's an overload for that method that allows us to specify when to pull again, and that's going to be through the retry after header, which the logic app's runtime will also honor. Now, in the case that we don't have any content, in the case that nothing has changed, or we don't have anything to share, what we can do is we can use the request.eventWaitPoll. So eventWaitPoll is a extension method also provided by TRex that gives us a 202 response, and again emits a location header based on the parameters, and it also can emit a retry after header. Here you'll notice the retry delay is being set to timespan.0. Now what that indicates is that we're going to go ahead and fall back to whatever was configured in the logic app. So maybe the user said, check this page every 5 minutes. I don't want to suggest, well, I think we should check it every 2 now, without any visibility of what they even said. So we want to honor their setting. We can say timespan.0. Otherwise, if we know that data is imminent, I'm waiting for the solar eclipse to happen and I'm refreshing a page, years ahead is going to be once every week to see if there's any updates on the progress of the sun. But as I get closer, it's every second. I want to check every second, and eventually I go blind. So that's why we're using logic apps for safety. All right, so I'm going to go ahead and save that lovely change in there where we're adding in the ability to tell it wait, try again later. And I'm going to go ahead and publish that change. All right, now as I go out there and I publish my logic app, as I publish my API, we're going to head over to the logic app's designer to see what this trigger looks like. And we'll also notice that it is definitely a trigger. So what I'd like to first do, though, is this ceremony that we do anytime we publish, which is to close Edge and open Chrome. And as I open Chrome here, I'm going to go ahead and scroll down. You'll notice I'm in the logic app's designer, but I don't yet have a logic app, so I'm selecting my template. I'm going to select blank. And I'm not going to start with any of the out-of-the-box stuff. I'm going to go ahead and type instead Azure App Services, and I'm going to select the Azure App Services action, and I'm going to type TRex videos. And we'll find that we have our lovely thing there. All right, now you'll notice that it suggests that we can now pull for updated web page content. That's a beautiful thing, and we can even say what frequency we want. I want to check every 5 minutes or maybe every 5 days. And I can check whatever page I'd like. So maybe I want to check the U.S. Naval Observatory Master Clock. That sounds wonderful. All right, so I'm going to go ahead and grab that. Thankfully, I'm not in Eastern time because, wow. And as I type that in there, or paste that in there, because I'm kind of lazy like that, it suggests that I should probably select something out of that page. I shouldn't just go there and run away. So I'll notice that most of the content on that page is wrapped in a pre-tag. So I'm just going to select all the pre-tags and I want to see all those, what they contain. And if they change, specifically if they change, I want to fire this. And maybe I use that. Maybe I go out and I say, well, after this fires, I'd like to make an HTTP request over to, let's do a little GET request here. Let's go out to Bing, because I feel bad about closing Edge earlier, so we'll give Microsoft a little bit more love. And then you can have a custom header. And notice I have as an option my results from the page. I could actually send that out in a header. Oh, that would be weird. I don't know why I would do that, so let's not do that. But let's pretend that we did anyway, because we can. In fact, I could go and for each through those because there's multiple potential matches. Now, it doesn't know that for real until I actually run it, but it could be an array of content. All right, so I'm going to go ahead and save that, and I'm going to go and look at the overall overview page, and I'm going to run the trigger. Now, you'll notice its first run, it was skipped. It went out, it got the page, content was what it was, it didn't know if it changed, so it set a baseline. And after I run the trigger again, you'll notice that it fires. Now, my logic apps run actually failed. I'm going to ignore that. Likely I was doing some insanity as I'm passing multiple line text as a header. But if we take a look at the trigger and its success, you'll notice that as far as the outputs from it, that it has baked in a location header. And in that location header, you'll see that it has a last result value. And so that's going to be the hash of the content it last saw. Now, the content it last saw, you can see has tabs, it has, new lines. It's not going to work in a header. So that was kind of a ridiculous example, but just to show that we can see the beautiful description of that in the UI, it certainly has that. All right, so that's an example of a polling trigger using the trigger attribute, using the internal visibility on the last result. Notice that wasn't a property on the card at all. And using the extension methods to make sure that we're returning either a 200 OK with the body when we have a result, and of course a location header of where to poll again, as well as a 202 accepted when we don't have a result. All right, so that's all there is to it for polling triggers. It's pretty straightforward stuff, and it can up your game to the next level. I hope you join me for the next video of the series where we'll be looking at all the dynamic things we can do with dynamic values and dynamic schema. Thank you for joining us, and have fun playing with TRex.
If you would like to help send me to college, please donate to maryscollegefund.eth. Thank you.